greatest common factor, or GCF, at some point in elementary school, and then probably as you go on into high school and later on, you're going to be using these greatest common factors to try to help you. One of the ways that we use it to help us is actually it's pretty useful for reducing fractions. And I guess I'll put up a link up above if you will want to watch it. Okay, so for reducing fractions and how I utilize these greatest common factors for that. Now, within this video, I just want to show you about this greatest common factor. So first, let's kind of dive in and remind ourselves, okay, so what exactly do we mean by a factor? And when you're studying these greatest common factors, you typically will be studying them just starting off with just natural numbers. So some positive, basically whole numbers that you have. So if you take a number, let's say like 100, you want to be able to know, okay, so what is a factor of 100? Well, it turns out that kind of a nice, maybe easier way to think about these factors is any number, so any number that you can take, so it's some number that basically evenly is divisible into 100. So you can take the number and then divide it into 100 and you're not going to get any remainders. And that turns out to be a factor. So for instance, if you take a number like 100, we can say, now there are many factors or many numbers of this 100 that go into 100 evenly. So for instance, you can take the number 2 and you can check that 100 divided by 2 is going to give us 50. So it's going to break this 100 into basically 2 multiplied by 50. And we say that this 2 right here is a factor of 100. But if 2 goes evenly into 100 and it gives us an answer of 50, that means we can also take 50 and divide it into 100 and get back our 2. So 50 is also a factor of 100. And this is what we mean, that there are many factors of a particular number that you have. Really, the only numbers that are natural numbers that don't have multiple factors, so more than just one, are basically prime numbers. Because prime numbers, if you remember, are only divisible by 1 and itself. That's it, and that's what makes them special. And in fact, we're going to be using, and I use prime numbers, to really just find these greatest common factors to have a systematic approach. Now, if you've forgotten about prime numbers, I'll put up a link up above, but I will assume that you are familiar with prime numbers for this video. So now, what other factors might we have for this 100? Well, there are, as I said, so there are many. You can take the number 10, for instance, and you can divide it into 100, and you're going to get that 10 gives us a result into 100 of 10. So now what we have is 10 is also a factor, and it's actually a factor twice of that. So again, any number that you can divide into the number of interest and it goes into it evenly turns out to be known as a factor. So here I have, 2 factors right here, and then I have 2 factors right here. Now they're exactly the same, the 10 and 10. And you can continue this pattern, right? You can continue breaking down these, and what you can do is you can break it down in terms of primes. Because you may remember that any composite number that you have, which is basically any number that's not prime, is made up of just prime numbers. And those are the actual factors that we have. So within here, I can also say, okay, so I can continue this trend, and I can now take my 50 right here, and I can now again break it down further. So that 50 has also factors, right? Now 2 goes into 50 again, and what I'm going to get is I'm going to get 2 multiplied now by 2 times 25. So now I have 3 factors that make up my 100, which is the 2, and the 25. Now, the 2's are prime, so I can't break them down any further. The 25 is not prime, because 5 goes into that 25. So what I can do is I can say, oh, okay, so I can take my 25 and then break it down in terms of its primes, which is just 5 by 5. And now here what I have is I have 4 factors. Now they are repetitive, the 2 repeats twice and the 5 repeats twice. But this is as far as I can break down the 100 in terms of factors, because they're all prime. I can't divide them any further to make them simpler. Now I could have gotten that also from the second one, so from the 10 multiplied by 10. So it's not unique how you find these actual factors and then how you find the actual prime, which we call prime factoring, okay, for these particular numbers. So you can take the 10, and the 10 is just simply 2 times 5. You can take the other 10, and it's also 2 times 5. And notice you return to exactly the same thing. Now the order is different, but in multiplication, the order is irrelevant, right? So I can just rewrite this from typically the smaller primes, and then it goes to the bigger primes. So they're identical. So that process is not really unique for all the numbers. But I do want to kind of say and mention these primes are kind of useful. So now what it is what is this greatest common factor? I just gave you a number, right? So now we know what these factors are. They're just numbers that can be divided into, okay, our original number that was given to us. But what does it mean to have a greatest common? Well, in order to talk about common factors, then that means you need more than 2 numbers. So if you mention, so for instance, if I take my 100, and then let's say I take like a number like 25. So now I have 2 numbers. Now they both have factors that go into them, right? I can factorize the 100 and I can factorize the 25. Now, for me, what I want to be able to know is, okay, what is the common factors in between them? Now, I've already done 100, and 100 was 2 multiplied by 2 times 5 times 5. Now, the 25 really has just, okay, it can be factored into 5 multiplied by 5 because those are primes. And here, what you notice that, oh, there are actually common factors. The 5 is common to both, and that's what we mean by a common factor. And then here, this 5, okay, is also common to both. So there are 2 5s. The 2 is not common, so it's a factor of 100, but it's not a factor of the 25. So 2 is not a common factor. So what we have within here is the common factors are just the 5s. And if you want to find the greatest common factor, then that means you would just take these. So in this case, these particular primes, okay? So you'd take all your prime numbers that are in common in between them. So in this case, the 2 5s. And if you multiply these, so what you're going to get is you're going to get 25. And what that tells me is that this is the greatest common factor. It's the biggest number that I can take that will go both into 100 and into 25. Now, clearly 25 goes into 25, but then we also see that 25 goes into 100. And that's the biggest number that I can take. That's why we call it the greatest. And it's common because it is possible to do it into both numbers. And it's a factor of both of them. So that's why we call this the greatest common factor. Let's see a few examples of how I actually break it down. I use one systematic approach for the greatest common factor, and that is just prime factoring throughout. So let's see how I can do that. So here are 4 examples. There are 2 numbers. Again, you always need at least 2 to find a common factor because you want to find a factor that goes into both numbers. But it doesn't have to be just 2 numbers. It can be 3 numbers, as I have in the 4th example. And I'll show you that the process is the same. So within here, if I take this, okay, so I have 2 numbers. What I like to do is I like to write them. I typically write the smaller one first, and then I will write the larger one. Now, I don't know, how sometimes you are taught this, but what I like to do is I kind of write them out in this little table for myself. And then what I do is I recall all my prime numbers that I have. So 2, 3, 5, 7, 11, 13, okay, 17, okay, and so on and so on. So it's good to remember these. Well, the next one is, I guess, 19. But it's good to remember the first few primes. And what I will do is I'm going to try to see, okay, if I can find, okay, first the smallest prime that goes both into 18 and into 70. And this is where we use the divisibility, right? So it's kind of useful to know when a number goes into another number. So I start with the 2, and I'll say, okay, does 2 go into 18? Yes, it does. Does it go into 70? Yes, it does, because both numbers are even. So what I'll do is I'll write the 2, and then I'll divide these by 2, so which is going to give me 9, and then it's going to give me 35. So it basically reduces my original numbers by that factor. But all I've done really is just division. So 2 is going to be a common factor of both 18 and 70. And now I continue and I check, okay, does 2 work again? No, 2 doesn't go into 9, so I basically just throw out 2 now. And I move over and I try to see, okay, does 3 go into both numbers? Well, it goes into the 9 itself, but it doesn't go into the 35, right? So I'm kind of stuck, right? I can't really go any further. Now, once you do notice that a prime goes into, okay, the number, you can actually still break it down. Now, the reason for that is because you want to get that number smaller and you want to see which primes it's made up of. So you can see that this, if I divide 3 into 9, it's going to give me 3 by 3. And you notice that, well, really the only primes that I can use are going to be 3. There's no point of me going any further, so to 5 or 7 or 11, because those will not go into my 9. So I basically can stop here. So I'm going to stop right here because what I have is the only factor is really 2. 3 goes into the 9 and it breaks it down into 3 times 3, but it will not go into the 35. In fact, the 35, if you think about it, okay, the only next prime that will go in is 5. And that's going to give me 5 times 7. So notice there's nothing in common here, right? So you have a 3 times 3 and 5 times 7. So those are not in common. And it turns out that then this must be my greatest common factor for 18 and 70. That is it. And you stop here. Let's take a look at the second example and try to see, how this pattern continues. I'm going to remove these, and let's now take what we have for our second one. So in our second one, so now these ones are much bigger. So I have 180, 450, okay? So this is what I have within here. And now again, so I'm going to just to use primes. You don't always have to use primes. In fact, I can see that the number 10 will go into both, because it ends in 180 and then 450. So you're not stuck just using primes. If you can very quickly see one factor that will go into both, you can utilize it very quickly. So I'm going to utilize the 10 because I know that it goes into both, and it's going to reduce these for me quite a lot. It's going to reduce it for me to 18 and 45. So 10 is definitely a factor. Now let's see if I can break the 18 and 45 with other factors that might go in. And here, okay, I can still see, all right, well, I'm going to try to use the number 2. Well, 2 goes into 18, it won't go into the 45. And that's okay, right? But what I'll do is, since 2 goes into 18, I'll break this down. It's going to be 2 times 9. And now what I notice that, oh, wait a minute, 9 goes into 18, but it also goes into 45. So if it goes into 45 and 18, okay, so that means that, oh, great, so that I can now take the 9, and it's going to break down my 18, it's going to just leave me a 2, and then 9 into 45 is going to leave me a 5. But now what I have is I have a 2, and then I have a 5. Notice 2 and 5 have nothing in common because they're primes. And because they're primes, I stop. So that means that the factors that I had were 10 and 9. And now what you should do to find the greatest common factor, you just take these factors that you used and you multiply them. And when you multiply them, you're going to get your greatest common factor, which is going to be 90. And now you can still check. You can say, okay, does 90 go into 180? Yes, it does. How many times? 2 times. Does 90 go into 450? Yes, it does. How many times? 5 times. Now, would you have been able to see this right away? Maybe, I don't know, but this is at least a systematic approach. So find factors, and if you can't find the factors, just start using primes. That's it. You don't have to use anything else, because ultimately every number is made up of prime numbers, right? You can just multiply them through. Let's take a look at that third example. So the 165 and 231. So let's try to break it down again. So as you're starting, you can think again of primes. Now 2 is not going to go into 165 and it's not going to go into 231 at all. But, you notice that, hey, wait a minute. So what about 3? Now, if you recall, to check if 3 goes into a number, all you need is the sum of digits, which means instead of doing the long division right away, you can actually just check very quickly by adding up the digits. And when you add them up, so 1 plus 6, 7, plus the 5 is going to be 12. Okay, and you notice that, 3 goes into 12. And if it goes into 12, that means it also goes into the original number. So that's called the sum of digits for 3. So 3 will go into 165. And now, does it go into 231? Again, you can do the same thing. You can add up the digits. They'll add up to 6. Okay, and then, hey, yep, it goes into 6. So that means it also goes into 231. So 3 is going to be able to go into both of these. Now, you can do the long division if you like. I can see that, okay, so 3 into 165 actually goes in, this is going to be 55 times. 3 into 231, this one I can't see that quickly, so let's take a look. So 3, so that's going to be 7, so 21 minus, it's going to be 21, okay, so 77 times. All right, so now I have that. Now, the next one is, okay, so the next prime. So 3, 5 is not going to go into 55 because 5 plus 5 is 10. So that's not going to work. The next prime is 5. So I do see that 5 goes into 55, but it's not going to go into here. However, okay, so if it goes into this, it's actually going to be 5 times 11. And this helps us, okay, this breakdown, because I noticed that 55 has a factor of 11. And that 11 and the 5 are prime. So I can't reduce them any further. So really the only thing that I now have to check, 5 won't work, but let's check if 11 goes into 77. And it does, right? So I'm going to say, okay, so 11 goes into 55 5 times, goes into 77 7 times. And now you've reduced it to a 5 and a 7. And that's pretty much as far as you can go. You can't break down the 5 and the 7 because they're prime. So to find your greatest common factor, what you do is you're going to take these two numbers, the 3 and the 11, and you multiply them. And that gives you your greatest common factor, which is going to be 33. And, you can check it back in, okay, and divide 165 by 33. And then you can check, okay, and take 33 and divide it by 231. And you'll notice that they do go in, and the result is going to give you 5. and it's going to give you a 7. So that's that example. All right, so starting off, I noticed that they're all even, so I'm going to try to divide this by 2. So I'm going to have 15, so this now by 2, this is going to be 42, and then this divided by 2 is going to be 63. So there you go. So that's my first factor, which is going to be 2. Now, okay, I noticed there's 15. Well, 15 is really 3 times 5. Okay, so now let's check if 3 goes into all of them. Well, it goes into the 15. 3 goes into the 42 because 4 plus 2 is 6. And then it goes into the 63. Okay, again, if you forget, so 6 plus 3 is 9. So 3 will work. So this is going to reduce this to 5. Okay, so 3 goes into 42. So I guess it goes 10. Okay, and then 1, 2, 3, 4. So this is going to be 14. And then 3 into 63. So 3 into 6 goes 2 times and then 1. And this is really as far as I'm going to be able to push this. Why? Because I have a 5 here, which is prime. And I can't reduce that any further. Which means that, well, 5 doesn't go into 14, okay, and it doesn't go into 21. So I have to stop. So my greatest common factor is going to be the multiplication of these two numbers, which is going to be 6. And that's your greatest common factor. So that's what you can use. You know, you can definitely try to break these things down in terms of primes, to slow yourself down. If you notice, you know, you can utilize and reduce them a little bit to make the numbers smaller. Okay, but this table format is kind of useful to have to find these greatest common factors. Now, as I said in the beginning, you know, one key application is, you know, reducing fractions. And you can use this method for that, because a fraction is just a numerator over a denominator, and what you're doing is you're trying to really find the greatest common factor for both, okay, the numerator and denominator, and then reduce them. You can go back to the start of this video and click on that link if you wanted to see that. All right, thanks for watching. We'll see you in a future video. Bye, everybody.